there's a problem, right? So you have to really target some specific applications that do this. The attack motivation, there's no discipline because I have people leaving and coming. It's really distracting. I told it a long time back. If you really want to leave or go to restroom, whatever, just go before the class. Okay. Now, what is the motivation for the attacker to launch this? He wants to deny the target to be able to access some resources. Basically, say if he wants to fill up the memory, then a genuine application or even other users running on the system, if the system is being shared, if a server is being shared by several clients, then the attacker wants to deny the other genuine users to be able to access the resources. Now, any skill or knowledge is required to launch this attack. How to really have a compressed version of size only 10 kilobyte, if the uncompressed version is 1 terabyte, that's a real skill is required to do that, right? So coming up with such a real compressed file is a lot of work, so a lot of skill is required. But once that technique is found, someone finds a technique to compress such a huge file to a very small file, you can launch the attack without any major skill required, right? So the only time you need a skill is how to do this. And once you do this, you can figure out what applications really do such things, what applications really uncompress and load the thing, right? So that's what I said here. So creating the exploit requires a considerable amount of skill, but however, once such a file is available or once such a technique is available, anyone can really launch this attack quite easily. Okay? And what are the resources required? You don't need any resource. Once you're able to locate such a technique or file that is really representing a huge uncompressed file, you can launch the attack. Okay? So what's the solution? The solution to mitigate this attack is that whenever you're developing an application that deals with compressed files, okay, you have to watch out how large the decompressed file is. So when you're decompressing or uncompressing, however you want to call it, you have to find out how much you have decompressed so far. If there is a limit like the read line thing that we saw the other day, if you are reading more than a certain number of characters, you have to stop reading. So likewise, if you are uncompressing more than certain bytes, you have to really stop uncompressing it. Also, you have to, because sometimes the compression ratio is available, right? If you look in Windows, the thing, you have a compression ratio for all zip files, right? So if you have files with a very low compression ratio, it means what? There's a possibility that someone is like, because this file is a very low compression ratio, isn't it? So if you have to work with a file that has a very low compression ratio like this, you have to be careful. So your application has to be kind of it depends on how we look at it. This actually should be called large compression ratio or high compression ratio. If you are able to compress 1 terabyte to 10 kilobyte, it should be called high compression ratio. Yeah, because if you are able to, let's say, compress 1000 bytes to 10 bytes, the compression ratio is what? 1 minus 10 over 1000. That's going to be 1 minus 1 over 100, that's going to be 99%. Okay, so if you are able to compress 1000 bytes to 10 bytes, this 99% is a compression ratio. Okay. On the other hand, if you are able to compress 100 bytes to 10 bytes, the compression ratio is what? 1 minus 10 over 100, which is 1 minus 90% still. Okay. So you have to really watch out for the compression ratio of the file that you are working with. So if the compression ratio is quite high, it's suspicious that the uncompressed file would be very large. Okay? And if the compressed file is very small and the compression ratio is very large, you have to be very careful. Like here 10 kilobytes and the compression ratio is very large, then you have to be very careful. So where this all could be launched, especially with image applications. If you work with JPEG and all this, in JPEG itself is a compressed format of an image. Okay, and gzip. I don't know if you work with gzip. It's kind of file that you can load on a web browser, I believe. Yeah. So it depends on what kind of applications you're working with. You will have to be kind of, because this is without what? Developing any code. If someone really tells you, I want you to develop an application that handles compressed files, you have to know that this vulnerability could be there. So to mitigate the vulnerability, you have to what? Watch out for the compression ratio, the compressed file size and all those things. So before going and implementing, you have to take into consideration all these possible vulnerabilities that could be there and develop the code that could avoid the threat. So that's what we are now doing in undergraduate level, like most people are doing, right? You are trying to incorporate security right from the requirement stage, not at the end. After someone has developed the application and then you experience all these problems, you develop a patch code that goes and fixes the problem, right? You don't want to develop any more patch code. You want to go incorporate security right from the requirement stage. Okay, take into consideration all these things. So I have another example here where this is for shell command injection attack, which we saw already the database SQL injection attack. So let's say there is a cat command. I think we have used cat by now, right? It basically prints the contents of a file, isn't it? If you work with Linux, cat, you type a file name a.text, it should print the contents of a.text. Okay? So now if you embed means what? Incorporate the cat command inside a program. So at runtime, the user can enter any file name and it's supposed to print out the contents of the file, right? And that's what I have here. So you expect the user, so the prefix for the file name is say some data log, and so now you embed this to the file name entered by the user, and then you say it should be a data file like this. So the user input is this component. So now it's very similar to SQL injection attack. If the user really enters only the file name, say readme.dat or whatever, then there's no problem. However, if the user can kind of inject a kind of a command like what I have there, let's say the file name, user name, whatever the name dot dat, right? Plus, not that, sorry. Semicolon RF. And then, so now this is the whole thing is the input entered by the user for this. So once you put a semicolon and then you have this dot dat coming over there, what is going to happen? This goes here. If the file is there, it's going to print it out, right? But RM is really what? Remove. And if you work with the options for remove, F, I believe, will remove without any confirmation. Normally, if you try to say RM, the file name, a.text, it's going to ask you, are you sure you want to remove? And you have to press yes. But if you say rm-f, I believe, and then the file name, or rf, you have to try it out and see, it won't ask you for a confirmation, it will just remove. I think F is for, hyphen F is for no confirmation. R is actually, now I say what, R is really the whole root. So it will, wherever you're running this program, the entire file system, everything from that will be removed. So if you're running this program and the root directory, okay, all your subdirectories, all your files will be removed from there without any confirmation. That's what you do rm-rf. Everything from that level without any confirmation will be removed. So recursive. Okay. So This is what is called a command shell command.